Hi guys, today we're looking at exercise 3.1 surd equations. So by the end of this lesson, you will know that to solve a surd equation, the method is isolate the surd, square both sides, and check your answers back into the original equation, as often one solution will not satisfy it. Okay, let's remind ourselves of how we can square brackets quickly. X plus a squared equals x plus a times x plus a. To expand this, we multiply x by x. We multiply x by a and get ax. We multiply a by x to get ax and a times a to give a squared. Simplifying this, we get x squared plus 2ax plus a squared. To quickly expand our brackets, we square the first value, multiply our terms together and double it, and square the second term. Let's try another example. X plus 5 squared gives us square the first term, x times x equals x squared. Multiply the first and second term together and double it. We get x times 5 times 2 equals 10x, and squaring our second term gives us 25. Let's try another example. X plus 7 squared. Squaring the first value gives us x squared. Multiply your values together and double it, gives us 14x, and squaring the second value gives us 14. Please also remember that the square root of any number squared equals that value, i.e. the square root of 5 squared equals 5. The square root of 18 squared equals 18. The square root of p plus 1 squared equals p plus 1. Let's look at an example. Solve 1 plus the square root of x plus 1 equals x. The first thing we must do is isolate the square root. That means we want the square root on one side of the equation and everything else on the other. This gives us the square root of x plus 1 equals x minus 1. From here, we square both sides. This leaves us with x plus 1. Expanding x minus 1 squared gives us x squared minus 2x plus 1. Bringing everything to one side of the equation gives us x squared minus 3x equals 0. From here, we want to solve for x, so we're going to factorise our equation. We do this by factorising out the common factor. X is in common in both terms. Factorising gives us x times x minus 3 equals 0. We now need to solve for x. To solve for x, we put what's outside the brackets equal to 0 and what's inside the brackets equal to 0. This leaves us with x is equal to 0, x minus 3 equals 0. Solving for x gives us x is equal to 0 and x is equal to 3. Our final step is to check our answers back into the original equations, as some of the solutions are not viable. Let's check for x is equal to 0. Substituting this into our equation gives us x plus the square root of 0 plus 1 equals 0. This leaves us with 2 equals 0. This is not true, and therefore x equals 0 is not a solution. Let's try for x is equal to 3. Substituting 3 into our equation gives us 1 plus the square root of 3 plus 1 equals 3. 3 equals 3. Therefore, x equals 3 is a solution of our equation. Okay, let's try another example. In this case, we have root x plus root of x plus 9 equals 9. If you have two surds, you must write one surd on one side of the equation and everything else on the other side. So we must isolate one surd. This gives us root of x plus 9 equals 9 minus root x. From here we continue with our steps. Square both sides of your equation. We're left with x plus 9 and 9 squared gives us 81 minus root x times 9 and doubled leaves us with minus 18 root x plus root x squared gives us x. Okay, so again, we want to solve for our surd, so we're going to isolate our surd. This gives us 18 root x equals 81 plus x minus 9. Simplifying, and we're left with 18 root x equals 72. We want to solve for our value of x, so we divide both sides by 18. We're left with root x is equal to 4, and square both sides gives us x is equal to 16. Our final step is to check our answer. This means we see whether x is equal to 16 is true for our equation. Substituting 16 back into our original equation gives us root 16 plus 9 equals 9. 4 plus 5 equals 9. And therefore, 9 is equal to 9. X is equal to 16 satisfies our equation and is therefore true. Let's try another example. The square root of x plus 7 plus the square root of x plus 2 equals 5. In this question, we have two surds. As we have more than one surd term, we leave one surd term on one side of the equation and move every other term to the other side to simplify the arithmetic. This gives us square root of x plus 7 equals 5 minus the square root of x plus 2. We now go back to our usual steps. Step 2, square both sides of our equation. This gives us the square root of x plus 7 squared equals 5 minus the square root of x plus 2 all squared. Expanding our equation gives us x plus 7 equals 5 minus root x plus 2 times 5 minus root x plus 2. Let's continue expanding our brackets. This gives us x plus 7 equals 5 times 5 gives us 25. 5 times minus root x plus 2 minus 5 root x plus 2 minus root x plus 2 times 5 gives us minus 5 times root x plus 2 minus root x plus 2 squared gives us plus root x plus 2 squared. Okay, here we're going to add together our like terms. We're left with x plus 7 equals minus 10 root x plus 2. So here we add together our surd terms. So minus 5 root x plus 2 minus 5 root x plus 2 leaves us with minus 10 root x plus 2. And then simplifying the square root of x plus 2 squared gives us x plus 2. Let's continue to simplify by adding together our like terms. X plus 7 equals 27 minus 10 root x plus 2 plus x. From here, I need to solve for my surd. So I'm going to bring everything to one side of the equation, isolate my surd again. This gives me 10 times root x plus 2 equals 20. Let's solve for x. Dividing both sides by 10, we're left with root x plus 2 equals 2. And now, to solve for our surd, we square both sides, and we're left with x plus 2 equals 4. X is equal to 4 minus 2. X is equal to 2. Your final step is to check if this value satisfies your original equation. So substituting in, x is equal to 2. On the left-hand side gives us root 2 plus 5 plus root 2 plus 2 equals 3 plus 2, which equals 5. And our right-hand side is equal to 5. Therefore, our value of x equals 2 satisfies the equation and is true. Please turn to page 65, exercise 3.1, and complete questions 1, question 3, question 5, question 7, question 9, question 10, and question 13.